Hello guys, in this video we'll talk about LSP or Language Server Protocol using Rust. We'll first start with the introduction to LSP, a basic overview of why we need LSP and how does it work, and then we'll build our own LSP and consume it using Rust. So let's begin. LSP or Language Server Protocol that your IDEs or any modern development tool use to communicate with your language server. Now, a tool such as VS Code, where we install extensions to literally use any language. For example, we are using a Rust Analyzer, which is an LSP for Rust language. Similarly, for different languages, there are different LSPs that you just download the extensions which initiate a LSP client to consume the LSP server and provide you all the features of that language, be it auto completion, be it diagnosis, or for that matter, like literally tracking all of what you are doing inside the particular file for that specific language. As you can see in this diagram, this is exactly how the communication between your development tool and the language server using LSP Language Server Protocol works. Language Server Protocol operates over JSON-RPC, JSON Remote Procedure Call, and if you are someone new to JSON procedure call, then I've already created a video. It should be popping somewhere on right top on JSON RPC using Rust. So make sure you watch it, JSON remote procedure call, before moving on to this one. So most of the communication, as you guys can see, is notification based, where each activity in that document from opening the file to the file closing is tracked. As you can see, text document, did open, did close, all of this we'll see with the implementation as well. And in case of any diagnosis, for example, you miss a semicolon or the brackets are wrong, all of that is also done using this publish diagnosis. And then any change that occurs and autocomplete to show, or IntelliSense that you can see, like while typing you get the suggestions, all of that happens using this language server using LSP. So as you can see, users open the document, users edit the document, user executes go to definition or any such command, which also occurs using LSP, and then users close the document. So this is how the typical communication looks like. To make it more easy, you can refer to this diagram where, as you can see, your extension host, as I explained in the start, like Rust Analyzer, for example, for HTML, then for PHP as well, different other extensions which host the language client and then communicate using JSON RPC with your language servers. That is basically LSP communication or language server protocols. So in this video, we'll implement our first LSP using Rust. And trust me guys, if you follow this video till the end, you will master of writing your own LSPs and consuming them. And JSON RPC, I already created a video, should be popping. Make sure you watch it, and we'll also consume our own LSP which we create. So basically we'll code both server side and the client side. So let's get started. Now move to the project explorer and make sure you have a clean Rust project. In SRC, add the client RS and the server RS. We'll be adding two separate binaries for client and server. Now move to cargo toml file, and here let's quickly add our dependencies. Now make sure in your extensions you have cargo extension installed, and you can also install toml extension. So as you can see, I have installed toml language support. Again, most of these extensions that we use in VS Code also use LSPs. So that's one of the reasons of using VS Code today. So we can, experience while we develop our own LSP as well. Now let's add our dependencies. So these are the dependencies that we need to do today. Serde for serialization, deserialization, Serde JSON for JSON parsing, Tokyo for async programming, tracing subscriber for tracing, and Tower LSP for adding our LSP. Because Tower LSP kind of provides you a structure to add your own LSP implementation, which we'll see in a minute. Now let's cover our binaries. So bin and name as client path as src client rs, and another bin that we have is name as server, and path as src server.rs. Now once all of this is done, make sure you have all of dependencies added and ready. Now move to client rs. Actually first we'll add the server side, so let's move to the server rs. Now in our first LSP, we'll create a very basic language server where we'll execute a command and return a notification. Now we'll look at all of the functions of LSP lifecycle, from initialized, shutdown, execute command, did open, and all such functions. And let's begin. Let's start coding. So let's say we have struct and we name it as notification params. So title as string and message as string, and then we have, let's say, description as string, and on top we'll just derive, debug, and serialize, deserialize. Now let's add a notification. So now here let's add an enum notification, or let's call it custom notification, and impl notification for custom notification. And here we have to add the type, so type params as custom notification params, or let's call it notification params, and const method as custom notification. Now let's add the backend, so we'll just say struct. Now I'll name this as backend, but you can name this anything that you want. Derive, debug, and client as tower LSP client. Now let's add the implementation for this, so we'll just say impl language server for backend, and here we'll just say async thread. Now we have to again add a few functions here. So the first one being async fn initialize, and initialize params, and result we'll just send back initialize result, and right here we'll just say okay, initialize result, and server info, if you want to present any, I'll just set it to none, capabilities, and server capabilities, and we can execute command, so we'll just add a execute command provider. Now this is basically to tell what the features or stuff that you support, so execute command options, and right here we can add commands, so vector of custom notification, so as a string, and then we'll just add work done progress options as default, and after that all other server capabilities we'll just keep default, and all other initialize result will also keep like default. Now that's pretty much for our initialize. So basically when our client first calls, it basically calls initialize. And similarly we have shutdown. So async fn shutdown and self and result unit, and here we can just return okay of unit. Now these both are required, so we already implemented. Other than that, whatever we want to, we can. So before that, let's look at what else we have. As you can see, initialize, then we have initialized, then we have shutdown, then we have the RPC did open, then we have did change, will save, and will save wait until, did save. We can use all of these, and while reading these you must be realizing that yeah, these are all the actions that a user perform, and in an ID, in a document, in a file, in a module, for example, right, while writing server.rs, this is exactly what we are performing. We are opening a document, we are writing, we are saving, will save, will close, and as you can see, go to declaration, and then there is go to definition, then there is go to type definition, then there is go to implementation, references, all these features that a language has. Prepare call hierarchy, incoming calls, outgoing calls. I mean, this is typical, all the features that we get, right? As you can see here, using Rust Analyzer, which is again an LSP that we are using for Rust. So super types, I mean, you name it, it has all of these, which obviously is not possible to cover in a single video, but I'll be adding lots of videos on LSP. So if you are someone interested, make sure to subscribe. Now let's add our own command execution. Now let's add the execute command. So async fn execute command and self params execute command params and result as option value. So here we can check for specific commands and provide separate implementations, but since we just have a single command, so we can just do params dot command is equals to custom dot notification. Now why this? Because as you can see here, we have clearly said that this is one of the command that we support, which is custom notification. So that's it. Or here, now let's say if you have multiple commands, you can just add bunch of else. So self dot client dot send notification, and here we can specify the types, so custom notification, and here we'll add custom notification or notification params that we just added. And so for notification params, we have a title string from, and let's say title as hello or hello notification, and then we have after title we have a message string from, this is a test message, and similarly we have description, so we'll just say string from this is description. Now you can write anything that you want, or you can even execute something here, but I'll just stick with this. And once we have this, we'll just say self dot client dot log message, so we can log, and we can say message type as info to track the journey, and here we can have a formatted message where we can say it command executed successfully and which params, and we can pass on our params. So that's pretty much for our log here. And okay, none. And since we are returning a result, so if that's not the case, then we have to add a else, and here we'll just say error invalid request. So we have our command execution as well. Now this is all that we want to do in our first LSP today. So here we'll just add async fan Tokyo man and tracing subscriber fmt it let listener Tokyo net TCP listener bind and 127.0.0.1 8080 await and wrap and let stream listener accept unwrap read write Tokyo IO split stream, and right here we'll just say let service socket LSP service new and client backend, pass the client. Now this is the same backend that we add right here, or struct, and as you can see we passed it right here. Now after this we'll just say server new and read write service wait. So our server side is ready with all of the implementation and things that we need. Now let's move to the client. So move to client RS. This would be a very basic implementation of client just to pass JSON-RPC. Now on the client side, we'll just connect to this TCP stream, and then we'll pass our JSON-RPC again, which we have to pass two. One for our initialize, and other one is for execute. So back to the client and async fn man result unit or box dynamic error from std error and Tokyo man. Now let's say let mutable stream Tokyo net TCP stream and connect. So let's pass the address 8080 await and let initialize request JSON. Now let's pass on the initialize request. So in a JSON-RPC request, first of all we have to pass JSON-RPC version 2.0, ID as initially 1, and method, so name would be the method we want to use. So here we want to use initialize, so just add initialize and params. So here we'll just pass process ID And for now, let's pass null and root URI. Again, we are not dealing with some documents here, so let's continue with null and capabilities as empty. Now let initialize request string. So initialize request dot to string. So let's keep moving to send out this. So to string, let's return OK of unit so we don't get this error. Okay, now it's gone. So let's say let initialize request formatted. So we have to format the request here. Content length as, and then we have our initialize request str dot len and initialize request str. Now let's do just stream dot write all and pass our initialize request formatted as bytes dot await, and then we'll just say let mutable buffer 01024 and let n is equals to stream dot read and mutable buffer. So just to consume our output, let response string from UFT8 Lucy and buffer to n, and here we'll just print received initialize response. Now something same we have to do for our next command as well, because it's not that a client can send a command and disconnect and then send another command. It's not like that. It's sequential. You have to first initialize and then you have to do the following order. So let execute command request JSON and again JSON-RPC 2.0 ID to method. ID is just your request ID, which should be sequential or continuous. So the command that we want to execute is, first let's just give the method. So the method is workspace method, so we'll just say workspace slash execute command and params. Now here we pass our command name, which is write this one, so we copy this name, and then our arguments, if any. So yes, in my case I do want to pass the arguments, so I want to pass title as hello and message as hello from client, and maybe let's also pass the description. So description, this is a custom notification from client, let's say. So it's up to you if you want to pass these arguments, because on the execute command, as you guys can see, we are not really using these ones, but we are just sending out our own. So if you want to skip this, it's fine as well. So we have our execute command. Now just do execute command str. So execute command request dot to string. And now just quickly let's do formatted command request format. And again, just like last time, have to add content length and then the format. So let's copy actually all of this and we can just quickly replace. So here we'll just say execute command str and execute command str, and then just same. So we'll just say stream dot write all, or let's even quickly copy this part as well. So here we have a buffer, and let's copy the write all as well. Okay, so execute command request or formatted, actually formatted command request, and then and we get our output, and let's quickly print it. So this is for our client, all in one man, but you guys can split these functions as well. So we have our stream here, we have our initialize request, and then we have our initialize request sent. After that, once we receive the response, we'll send out the execute command request and we'll just execute the command. So if you are till here following me, congratulations, you just write your first LSP, both server and client. Now let's quickly test it. So open your terminal and we'll have two instances of terminal, one for server and one for client. So on the server, we'll just say cargo run bin server quite, and on the client side, we'll just say cargo run bin client quite. Okay, so as you guys can see, we have our output. So the first request that we made was to the initialize. We executed initialize and we get our commands. In commands, we get custom notification command. And the second one that we have is execute command. So in the execute command, in our second request, we have, as you can see, this request. So here we have our params, and in the params to custom notification, we have the output. This is a description, this is a message, and this is hello notification. So this is all that we just sent from server. And then we have our log message, which we log. So as you guys can see, we have all of our things up and running, and as soon as the client disconnects after executing its command, the server also disconnects, as you guys can see here. So this is a pretty basic and naive example of LSP, and I hope you guys understand it. If you need code, you can comment down and share with your friends, and let me know what LSP or what language server will you like to build your own, and we'll also work on different other LSP lifecycle functions in future as well. That's it. Thank you.